Okay, so I'll come to add, and then I need to just search for LED. So I can look for LED 5 mm. So I still have a lot of options. Let me break the normal LED one. And then this is what I am looking for. Can you all see it?
Yes.
All right. So we can confirm that the footprint matches what we normally use in the labs. So I'll just press on OK, and then I'll rotate it with the click of the mouse. And then I'll place one here, another one here, another one here, another one here. And then I'll use the copy tool to copy this resistor. I'll rotate it, and then I'll place one here. Use the copy tool again, copy it again, copy it again in that order. And then after that, I'll use the net tool to join the wire from here to the existing ground. Join this to the ground, join this as well, join this as well, and then join this one as well, and then join that, join that, join this. And then I'll create some short wires here as well, like I did for the previous one. Okay. So I like to connect the LEDs from port D2 to port D something. So I can actually connect them using the normal wire. So I would like to allocate them to port D2 like this. And then I'll connect the next one to port D3. I'll connect this one to port D4. And then I'll connect this to the last one, which is port D5. Okay. So we've connected our LEDs successfully to the microcontroller pins, and then we have grounded the ends of the LEDs. The next thing I want to do is to connect the relays. So with the relays, let me change the screen I'm sharing to my browser so we can see what exactly I'll be doing. Okay, so I want to share my browser interface now. Can you all see my browser?
Yes.
Yeah.
All right, so I am looking for this relay. Normally when you Google 5-volt relay, I'm sure what will come. You see this blue relay? This is what I am looking for. So I'll be adding 2 of them. And then also, I want to use this module, 5-volt, 450 milliamps module. All right, have you seen this module?
Yes.
So what I want to do is, I plan to step down the grid voltage, which is 220 volts to 5 volts. And then I'll step down the solar voltage also from 220 volts to 5 volts. And then I'll feed the output of these small modules to the microcontroller to indicate that both the grid or the solar power source is available. Is that clear? So I'll use 2 of these modules, and then I'll add 2 of the relays into my schematic. But I want to show you what I'll be adding before I add them. All right. So I'll change my sharing now to the Eagle screen once more. Any questions so far? Okay. So the relay I am using, the name for it in Eagle is ZFM112. The reason I mentioned it is because I remember it. Okay, but when I search for it, nothing has come. So maybe I should just do *112* and see if I'll be able to get it. So I'll scroll down to relays and see if I'll be lucky. All right, so here we go. ZF112. This is what I was looking for. Okay. I'm going to add 2 of them. Let me just add them somewhere around here. 2 of them over here like this. And then the next thing I'll be adding is those 2 modules I spoke about. Now, those 2 modules normally don't come with Eagle. You have to find them and then import them into your Eagle. And a good place to get DIY modules is DIYmodules.org. It is a website that hosts Eagle libraries. I've pasted it in the chat box. So most of the modules we use on campus, you can get their Eagle library from that website. You can visit it to see what they have. But I promise you, they have a very wide variety of modules over there. So I'll click on add once more. And then when I click on add, I'm going to search for that library, DIY libraries. That's the name of it, DIY modules. So when you see here, I have my library name, DIY modules. So I think the first one here is this. Can you see? That's AC to DC 3.5 watt converter. Do you see an image of it over there? So I'm going to import 2 of them into my design. Now, the last thing I have to worry about is my power supply. It's my power supply. But let's finish sketching the schematic around these ones, and then I can now bring in the power supply. So I'll be driving the 2 relays with transistors. Okay, I'll drive them with transistors. And my favorite transistor is BC547. So I'll go once more to add, and then I'll search for BC547. So I have a number of them. I'll choose this one. The package I am choosing is what? TO92. TO92, which is the one you have in your kits. Okay. So I'll press on OK. And then I'll place one transistor here. And then I'll place the other one over here. And then the next thing I'm going to do is to copy the resistors I have here to bias this transistor. So I'll paste the first one here, and then I'll paste the next one over here. And then they are likely to go to the microcontroller. So let me now use the net to connect the transistors to the relays. So I'm going to copy the ground from here, and then I'll ground the emitter of this transistor, ground the emitter of that transistor. And then since these relays are 5-volt relays, I can power them directly with my VCC. So I'll connect this one to VCC, copy the VCC from here, and then connect this to my VCC. So I want to connect my relays to port C0 and port C1. I've taken those decisions on my computer already. So I'll just extend this briefly, extend this as well briefly, extend this briefly, and then extend this as well briefly. And then I'm coming to use the name function again. I'll call this one relay. I'll call it rel1, and then I'll place the label over there, and I'll call this one rel2. I'll place the label over there as well. And then I'll call this one rail 1, rotate the label, and then place it close by. I'll call this one rail 2, and then I'll as well place the label close by it. That way, I have connected my relays. The last thing I'll do for the relays is to connect a terminal block. A terminal block looks something like this. I'll change again to my browser interface and then share with you what I am trying to use. I'll share screen, and then can you all see my browser interface? So this time around, I am looking for this 3-pin terminal block because I'm going to connect a wire over there. Have you all seen this guy before? Have you seen this module before?
No, please.
All right,
Yes.
so it is just a place where you can connect wires to. Okay, it looks something like this. Do you see the hole in it? Those of you who have used relay boards before, this is the same thing they use on the relay board. Okay. All right, so I'm back to my schematic interface. So to find that terminal block, go once more to the library, and then you can find it in a library called Conwago. Conwago. That means that the manufacturer for that thing, the popular one is Wago, Conwago 500. So this is what we are looking for. Can you see that? You can look through the Conwago library whenever you are looking for this type of connectors, and you'll be very lucky. So I'll press on OK, and then I'll place the first one here, and then I'll place the second one over here as well. And then I'll use the net, connect from here to here, connect from here to there, connect from here to this one. Then I'll repeat for the other one as well. And then connect from here to here. All right? Correct. So I am done with the relays. Now, I want to connect the 2-pin type of terminal block to the inputs of these power supplies so that they will be the input of the grid and the input for the solar. So I'll go back again to my Conwago library, but this time around, I'll choose the 2-pin terminal block. So I'll take this one, bring it here, take this one as well, bring it here, and then I like to do this. I'll take this one. I want to move it and then just place it on it. Move this one as well. Place it on it. Move this one as well. Place it on it. Place it on it. Okay. So the output definitely will be 5 volts. I'm going to be using the out minus and then the 5-volt pin over here. But there is a problem. If we connect, when you read the data sheet of the microcontroller, there is a certain amount of current and voltage that can go into the microcontroller. If you feed more than that into the microcontroller, you are very likely to damage it. Okay, you are very, very likely to damage it. So what I will do is I want to connect some resistor over here to limit the current going into the microcontroller. So I'll take the resistor, I'll use the copy tool, and then I'll paste a resistor here. This value of resistance definitely will be very high. And then I'll be grounding the minus pin. So I'll copy the ground pin, and then I'll just do it like this. Copy this one as well, and then bring it here like this. And then I'll connect from here to here, connect from here to here, connect from here to here, and then I'll connect from here to there. And then I'll bring this one out a little, and then I'll bring this one out as well. a little. And then we would like to connect them to port B0 and then port B1. If you watch the schematic, those were the pins I used. So I'll go back here and then connect a short wire over here like this. And then I'll connect another short wire here like this. And then I'm going to name this one solar. And then I'm going to name this guy grid. So I'll come back here, name this guy solar. And then I'll name this guy grid. Is anybody lost? All right, the chat box appears.
Yes, so you don't get anything. Okay, me, I don't get it.
What's your name, please?
Please, I try to smile.
Were you here yesterday?
No, please. No, like we don't even know that we have a meeting like this. Like you just posted it.
Don't worry,
right
I
now.
will. This is targeting the final years.
So like we are friends, you know.
Yeah, you have your session. This is for the final years. That's the reason.
Oh, okay.
But don't run away. You can watch.
Yeah, I'll watch. No,
don't you see the final years are quiet?
Jesus.
Okay. Interesting.
Okay, so all right.
Can I move on?
Yeah, sure, it's fine.
Okay. Okay. So we are done with the output from here, and then we are done with the output from here as well. And we've connected them to the microcontroller. So what is left for us? Let me refer to the block diagram. So we need to find a way to program the microcontroller. Okay. So we said we will have a debug interface, and then we also have an Isp programmer. So the Isp programmer, it uses 6 pins to program the microcontroller whilst it is on the board. And it uses these pins, SS, MOSI, MISO, and then SCK. All right. So we are going to add that module to the board now and then connect them to the microcontroller. You can find the Isp. You can search for Isp in the library and see. So I have gotten it inside Adafruit. So Adafruit is a custom library I have put in my Eagle. And then when you put the Isp module, it looks something like this. Can you all see? So all I'm going to do is to connect this one to VCC. So I'll copy the VCC symbol, place it here, copy the ground symbol, place it here. And then I am going to name this wires, and then I'll find their corresponding wires so that we can connect it to them. Okay, so I'm going to use name, and then I'll call this one MOSI, and then I'll call this one MISO, and I'll call this one SCK, correct? And then I'll call this guy RST. Okay, so I need to call this wire RST so that it can be connected to the RST pin. So I'll call this side RST. And then I'm going to extend these guys briefly. Okay, I don't need this one. So I'll bring this one here. I'll bring this one as well here. I'll bring this one as well here. And then I'll use the name tool. And then I'll call this one MOSI. I'll call this one MISO. And then this one is the SCK. So that is my ISP interface. The last thing I'm going to do, the last two things I'm going to do is to add the debug interface. That's the serial port, which is these two pins over here, PD0 and then PD1. So I'm going to use a pin header. A pin header looks something like this. I'll share my browser and then share that with you. So stop share. And then I'll share my screen again to my browser. And then have you guys seen this before?
Oh, yes.
All right. So that is what I'm going to use. I'm going to use the So I'm going to use the 4-pin one. So I'll click on add once more. And then I can just type in space header. And then when I type in header, I'm going to look for the 1x4. It looks like something like this. Okay, something like this. And what I'm going to do is I'll just use the net, connect from here to here, and then I'll connect from here to the last one. And then I'll add my VCC and then my ground using the copy tool. And the last thing I'm coming to do is to add the power supply. So with the power supply, all I need is 5 volts. So I'll use the normal LM7805 to get it. So I'll click on add once more. And then I said yesterday that there are 3 approaches you can use when you are looking for something. 1, the manufacturer. 2, the actual name. 3, I forgot. So I'm looking for a folder called voltage regulator. So I see VREG and I see voltage regulators. Do you see that? So I'm going to break this down. Okay, so here we go. This looks like what I'm looking for. 78XXS. All right. So I'll click on OK. And you know, all you need to get this thing to run is capacitors. So I'll just come here. I'll go to RCL like we did yesterday. And then this time, I'm going to look for a polarized capacitor. So RCL. So here we go. So I can find polarized capacitors in here. So when it is red, it is surface mount. But when it is green like this one, it is through hole. So I'm looking for a capacitor that is roughly 8 mm wide. All right, so 6 mm looks good for me. You can see the 6 mm over here. Make sure you know the dimensions of the capacitor you are using before you choose it in Eagle. If not, it will become bigger or smaller than what you intended to use. So I'll place one here, and then I will just use this guy to connect this, use this side to connect this, use this one to connect this, and then I'll connect this side to it. And then I'll use the copy tool, copy my ground to this place. And then I'll copy my VCC because my VCC is going to come from here to this place. And then I'll copy the terminal block that supplies the power to it. And then I'll be able to connect from here to here. And then from here to here. So this is the final schematic of what I described in the project, in the videos we have spoken about previously. Let me go over the circuit once more. At the heart of it is the microcontroller Atmega 328P. And I said that you need 3 things to get it to run. First one is a good power supply. Second one is a clock signal. Third one is the reset signal. And then you are good to go. And then on the block diagram, we said we are going to have a debug interface. So we are going to use the 4-pin header over here as our debug interface. And then we needed to connect a number of accessories to the microcontroller. The first one is the push button. The first one will help the user toggle between manual and then automatic. The second one will help the user toggle between solar and the grid. And then we have 4 LEDs to indicate the various modes that the system is in. And then we have 2 relays that will be triggering between the grid and then the solar. And then I use a transistor to drive the 2 relays. And then when you come here, these are the inputs. You can use this one for the solar, and then you can use this one for the grid. And then the last thing is we need 5 volts. So we use the LM7805 to determine the 5 volts that we need. Now, before we move to the PCB, let's give values to all the components we have here. If not, our schematic is not complete. So we come here, we click on value, and then the first one here, resistor, we need to give it a value of, let's say, 470 ohms. So let's call it 470R. This one to the value is the same, 470R. And then the value of this one is also 470R. And then the value of this is also 470R. And then this one, I can use 1K. And then this one to 1K works fine. And then this capacitor, 100,000 UF. And then this one, I'll make it 100 UF. And then this one, I'll make it 100K. I'll make this one also 100K. And then when you come here, this one, 22 picofarad. And then this one as well, 22 picofarad. The crystal clock is 16 megahertz. And then this resistor is normally 10K. Okay. And then I want to name some components as well. So I'll call this one debug. And then the ISP has been named for us already. Let's call this one solar. And then let's call this one grid. And then we can change this one as well to solar relay. And then we call this one grid relay. All right, so we are done with the schematic. So the next thing I'll be doing is to switch to board. So you see the icon here, generate or switch to board. I'm going to click here, or I'll click on file, and then I'll click on switch to board over here. So it will ask you, this board does not exist. Do you want to create from schematic? You say yes. So when you say yes, do you see my new screen, or I have to reshare it? Okay, can you see my new screen now?
Yes, please.
Correct. So all the components that we were working with, these are now their footprints. Okay. Now it is our job to arrange everything nicely so that we can realize a very beautiful printed circuit board. So for this one, we are going to use our intuition to do that. Okay. So the first thing, you'll be using a lot of the move. You move, and then when you are done moving everything to the right place, then we can be able to route the board. So I'll first move the microcontroller. You can rotate once more by clicking on the right click button. And then I think I want to begin moving the huge stuff. Okay, let me leave the huge stuff at first. So let me see this one. This one obviously wants to go somewhere around here, okay? Because the yellow wires are concentrated around here, all right? And then the crystal wants to move somewhere here. So I'll rotate it and then I'll place it somewhere here. Now you can click on this tool. It's called rat nest. it will show you the shortest possible wires whilst you are connecting. Now, do you all remember that we used some capacitors for the crystal and they were close to it? So I'm looking for those capacitors and I want to place them as close as possible to my crystal. So I'll click on rat nest once more. Okay, now I want to move my relays to this far extreme end of the board. The first one has been moved, second one has been moved as well. And then I want to take their accompanying terminal blocks close to them. And then I'll bring this one as well over here. Okay, we are making headway. So let me click on the rat nest once more. Okay, now where are the LEDs and then their resistors? So I'll just take the LEDs from here. I think they will be better down here. And then this is the accompanying LED. This is the reset resistor. And then the next LED is this one. It goes here. And then the accompanying okay. I see some drama going on in the chat box. That's very fine. Okay. So let me click on the rat nest once more. So I think this is the first LED. It wants to go somewhere around here. Second LED. And then third LED will go somewhere around here. I'm going to rotate them so their grounds face the edge of the PCB. Okay, so we are making good progress. So I want the input modules to come down here as well. Okay, let me just put them here, close to the relay, so that all the high voltage stuff can be on one side of our board. And then this is the terminal block for this one. Okay, so I want to put these push buttons down here. And then the next push button over here. And then I remember there were some resistors that goes to, first there are some transistors that we connected to the relays. So I'm moving the first one here. And then the second one over here. And then the next resistor over here. And I'll click on the rat nest once more. It's making my life easier. And then my debug interface, well, I can put it here to the edge of the board. And then finally, my power supply. I can mount it over here. And I'll bring my capacitors over here. This is the output capacitor. And then this is my input capacitor. And then there are some resistors at the end of the these modules. Correct. So we are done placing the components on the board. Now the next thing I'll do is to reduce the size of the board by using the drag button like this. And then this becomes my final layout. Now I can do some few adjustments to optimize the connections. I see a problem here, and then I see another problem here, and then I see a few design issues over here as well. So let me resolve all of them. But I think it is best if this resistor moves up closer to the LED it is controlling to make the board look a bit nicer, like this, and then like that. Good. And then, well, I don't like the position of this terminal block and the push buttons. So what can I do?
Hello, Nicholas.
Yeah, hi.
So we have 2 minutes remaining, just in case.
Yeah. So just like yesterday, IT hasn't upgraded my Zoom account yet. So I'll pause now, and then when I come back, we can route, and then you can ask all your questions. After that, I will upload the video to YouTube, and then I will upload the files as well for you to download and watch. Okay. So let's go. The same link, just click on it again, and then I'll be back.